Hi folks, it's Bakgat time again. Thank you for watching. For the newcomers, welcome. Before we continue, click and subscribe, do all the yuppie stuff below so that we can keep you informed. And today, with me, a guest, Van Zyl.
Hello, Christopher.
How are you?
I'm fine. Thank you very much for the opportunity and welcome to you. We are very happy to be part of the Bakgat scenery.
Well, folks, today we are talking about annealing, right? The voodoo art of annealing. We're going to try and unpack it for you and show you what this beautiful product, myAnnealer, is all about. Van Zyl, before we continue, introduce yourself to our audience.
Okay, so it's easy. My name is obviously Van Zyl. You all know it by now. I'm very fortunate over the years. My career path took me from electronics, electrical, metrology, even ballistics, software programming, websites. I'm a jack of all trades and master of zero. And to get to the product we see today, I really had to dig deep. But fortunately for me, I have all the experience over the years. And it was actually nice to bundle all that together to get to the myAnnealer today.
Absolutely. Folks, let me tell you, Van Zyl here, a very well-accomplished gentleman. Too modest, but a very well-accomplished gentleman. From ballistics, let me tell you now, this is folklore in South Africa. Give us a quick rundown on myAnnealer.
In essence, we took out the rocket science or the dark science, dark matter, call it whatever you want.
The voodoo.
Out of annealing. Our main focus is consistency, ensuring each case is exactly the same. Irrespective of thickness, composition, whatever, the neck tensions to be all the same. And that was the motto from day one, to keep it simple and keep it consistent. And those are the two things that is our core values for myAnnealer.
So, if I understand it correctly, myAnnealer has two primary mechanisms or functionalities. One is time-based and one is sensor-based. Obviously, the uniqueness to this is the sensor-based. Elaborate quickly on that.
I would like to add, not only sensor-based. We really looked at all the latest technologies, touch screen and induction and all those fancy stuff. But sensor-based means we sense the temperature of the case while annealing. Also, the microprocessor is not displaying voltages or any other current readings. During the anneal process, it only looks at that specific level, ensuring each case is the same.
So each case gets annealed to the parameter ideal for that particular case.
Yes, we utilize infrared technology, in other words. Okay. Thinking of the not so long ago, we all walked around with COVID, thermal thermometers, blah, blah, blah. So think of the same thing. So we, in essence, are taking a thermal image or temperature of the case, comparing it to our setting, and irrespective of the thickness or the alloy composition, it will be exactly the same. And so far, we already see some very good results coming back from our customers.
Excellent. Let's take a quick look at the actual unit. Tell us about the features.
Obviously, we have our on-switch anti-emergency stop.
Okay.
Latest technology, touchscreen,
yes,
which means we've got memories for all the different setups. In total, we've got 15 memories.
Correct.
We've got a volt amp meter that is not connected to the microprocessor. Like I said, all focus is on the anneal process. Okay. We even have a little fan. Sometimes some of the media is stuck on the case and it produces
a little smoke. You just want to blow it away.
Yeah, just blow it away. And
how convenient is that, folks?
Yeah, and our little glow sensor. So we really try to think about all things possible and include it into myAnnealer.
Well, folks, I have to tell you, I've had one of these for practically the past 8 months, and it is just super magic. Hence, the reason why we are here, because this needs to be shared. I fully endorse the product. I think it's just next level. So, let's take a look. Let's go through the motions and actually do an annealing.
To me, that sounds Bakgat.
You know, folks, one of the biggest issues I have with all these fancy annealing solutions is the fact that I find it very difficult to do the setup, right? And you know, some of the brass are very expensive, and one is always cautious, and then you over-cautious and whatever goes with it. I want a simple process that I can understand, a process that I can repeat 3 or 4 times a day when I do different brass or annealing. So quickly, take us through take us through the startup motion of myAnnealer.
So obviously we've got memory. So when you start with, let's say, 760 or something, then you can rename it and store the settings. So next time you just recall. But the first thing we need to do is look at the feet here.
Yeah.
So I make sure that it's a tight fit as possible.
Okay.
And you just put it in the bed and you can fit it.
Oh, yes.
And see free falling.
All right.
Happiness.
Okay.
Okay.
So that's where it actually gets discharged.
Yes, yeah. So after the process is done, it will automatically just discharge. Okay.
Right.
So the next step is, so we need to adjust the height. So nice touch screen.
Yeah.
I press the test and ensure that it's the right level. So I've got a slider, I've got blah, blah, blah.
So on this slider, I can physically adjust the height.
Yes.
All right.
And you've got, from the center in total, you've got 40 millimeters
Of total travel.
of, let's say, beam of heat applied. So you've got a lot of space.
Okay.
For general cases, it's not that sensitive. When you go like the BR kind of cases, you need to be...
The heavy overboard cases.
You need to look at the thermal center and you need to look at the gradients. But for normal stuff, this is easy. So let's assume I've done the height and the glow level, we keep it 950. And then next we go to the magic anneal screen.
Right.
So it's going to go up to whatever we've programmed, and I press anneal.
Right.
It does preheating, all the fancy stuff. There's some algorithm pulsing the heat, done and dusted.
As simple as that. Well, let's run a few.
Okay, so now I'm going to go to auto mode, which means it will sense the case and it will just anneal. And there it's going. And when it's done, it will drop it, and I put in the next one. And that you can do until
it's
your
as
coffee
simple
is
as
done.
that. There's the magic.
That's the voodoo.
Now, folks, I have to tell you that when you look at the actual glow image, you know, under normal lighting conditions, it is very difficult to actually observe and make a decision whether you are annealing to the right temperature. Hence, the thermal sensor.
Yes. Yeah. The theory says that in a light condition like now, you want to see a light red.
Yeah.
I think it's like a rose red.
Yes.
Go to the garden, look at the pink rose, and this is what you want to see. So, for me, when the lights are on, I want to barely see the red.
Of course.
And when the lights are off, you want to see a decent red.
Of course.
The theory is that 97 or 98% of all metals glow at the same temperature. And you want to stop it just before the glow at that point. So this is the logic.
But the problem is that the bandwidth or the wavelength in terms of the thermal signature or the emissivity, your eye cannot distinguish that fine distinction. Yeah. That's why you need a proper sensor.
If you anneal like 222s, smaller cases, in many instances you won't even see the glow.
Yes.
It's like 2-point-something seconds done and dusted. Switch off the lights. I usually say to customers, get some old cases in the beginning.
Yes.
Familiarize yourself with your tools, like any other stuff or gadget you buy. Some that you can destroy and go for it. So in this case, you don't need to destroy any cartridge to get some kind of reading. Remember also, if you use your first cartridge as a killer or whatever you want to call it, it doesn't mean that all the others are the same. So whatever
exactly.
you've done
This
with
is
the
the
first
problem.
one, yeah.
This is the problem.
And also, when you look at your BR type cases, just apply a bundle of heat might mean that some area like the neck is now overheated.
Of course.
Just trying to get heat to the shoulders.
Absolutely.
So here you can very specifically apply the heat at a specific place. And I think somewhere there's an article talking about the thermal center and the gradient. So those are the factors you need to include in your
Whilst we are talking about gradient, let me quickly explain, folks. As the case, remember this originates from a flat piece of metal. It then is turned into a cup, and it's so-called drawn. When this is drawn, the material at the bottom is thicker, and there's reasons for that, so that you don't have head case separation, etc. And then, as it gets drawn, it obviously gets thinner towards the mouth. But here's the problem. It also differs between there and there. And when it comes to coaxial tension, what we need to understand is that it needs to be consistent. So if you anneal time-based, what you're going to end up with is perfectly time-based annealing. But the annealing per case, or what is required for that particular case, even within good quality brass, within a batch, you are going to find that certain cases will anneal 0.02 longer or 0.02 shorter or whatever. So the ideal is to make sure that you anneal the case, the neck tension for every individual case to the absolute where you need it. Now, when it comes to military cases, it only gets annealed once, and it gets annealed at a very low temperature, only about 270 degrees. And the reasoning behind that is that you want a very heavy coaxial tension, because remember, the cartridge is loaded once, it's going to be disposed of in a military environment, and it's never going to get reloaded again. But when it comes to sport shooting cartridges or higher grade hunting cartridges, of course what you would want is a consistent neck tension. And this is where people make the mistake. They think that neck tension has to have a specific tension. It has to have a specific tension for a specific application. If you are going to reload 450, 500 or whatever cartridges, where you have a double, you want to make sure that that neck tension is going to be tough enough to retain the bullet in the same position whilst you fire off the first round, or typically in a revolver or whatever.
Coaxial stiffness is key.
Exactly. But the point is, it needs to be applicable to that application. If you are shooting bench rest, where you are shooting with a single action rifle, the seating is actually so soft that you can press it in with your finger. But you still want the coaxial tension absolutely similar from one case to the next. So tension per se is not the crisis. It's having it consistent.
Consistency
That's
is key.
the big issue. So let me explain to you quickly what the implication is in terms of real-term application. If your neck tension is directly equally related to your SD, standard deviation. Now, if you run a standard deviation of over 15, then you are technically running a standard deviation for a large caliber hunting rifle. If you are shooting a sports shooting rifle, it needs to be 10 or less. Now, if your neck tension, if the SD is somewhere in the region of 15, your predicted impact, all things being equal, your predicted 1 MOA impact at 1,000 meters is only somewhere in the region of the high 20s, let's say 28%. If the SD is down to 10, that impact predictability goes to somewhere in the high 60s. So let's say 68%.
Huge improvement.
Huge improvement. And then, of course, if you can get it below 5, then you are running easily in the high 90s, 95, 96%. And that's where you want to be when you are talking about precision. And it all starts with good annealing.
Christopher, you're 100% correct. I get this question very often. What must I do to shoot better or more accurate? And for me, the key word is consistency.
Absolutely.
If you decide to deep prime and then clean and then anneal, keep that process the same.
Always.
Don't change anything.
Always.
Consistency. Even, let's say you are new to this process and by some odd reason you over anneal 10%. Why do we anneal? Firstly, it started off by saving money.
Of course.
And secondly, we saw, we can now get a consistent neck pressure.
Absolutely.
So if you, let's say you've got a batch of 100 and you are 20% under annealing, or pick a number, at least that 100 will be all exactly the same. So you can already start do adjustments because now you've got a solid foundation.
Yes.
So from the scales and everything you use, and you start adding all your unknowns, suddenly it gets to a big number. We as humans, we contribute a lot of variables to the equation.
Of course.
So those are the things you can control, but to some extent, because high blood pressure influence your eyesight.
Absolutely.
Maybe a bit of beer the
Absolutely.
previous night, stuff
Absolutely.
like that.
Absolutely.
So the things that you can control, you must control.
To a point.
Yes, from metrology they talk about the uncertainty budget, meaning you need to identify all uncertainties.
Yes.
And annealing is one huge contributor to that uncertainty.
Absolutely.
And then comes a scale and all the other stuff,
Of course.
and at the end, you yourself the shooter. So this is
Next
good
thing,
stuff.
guys, the message here is any form of annealing is better than no annealing. But if you're going to be spending the time, money, and effort to anneal, do it right. It's as simple as that. So, let's do a couple of anneals for you, and let me share a few interesting facts. I think it is very important for our viewers to understand what annealing is in principle. What is the definition of annealing? In principle, thermal annealing is the process of heating an object to a single phase field above the crystallization level, followed by an equilibrium cooling with the aim at achieving equilibrium. In other words, simply put, a stress-free microstructure. So, in other words, you want to anneal the material to the point where, let's say then, all the microstructures align and it becomes stress-free. So the myAnnealer, the method that we are demonstrating, is based on thermal temperature sensing. In other words, we talk about the glow image, right? The thermal image that you're looking at, we talk about the glow image as the foundation or the basis for deciding the exposure time. So what is emissivity? So emissivity of surfaces of material is its effectiveness in emitting energy as a thermal radiation and varies on a scale, it's measured on a scale from 0 to 1. Now let me give you an example. Dull brass has an emissivity ratio or rate of 0.22. A natural rolled brass plate will only have an emissivity of 0.06. Polished brass will give you an emissivity rate of 0.03, and an oxidized brass will give you 0.6. And this is all now at 300 Kelvin. So what is the relativity of this? We need to understand that when you anneal, your annealing process, like the rest of your reloading process, has to follow a set recipe. In other words, if you are going to first clean your cases before you anneal, then that is what you do every single time. If you decap and then anneal, then obviously the residue on the actual brass is going to give you a slightly different reading. So you have to follow a set protocol. Right. We spoke about temperature-based annealing management, and then we talked about, let's call it a sensor or thermal-based annealing management. I'd like to give you an idea of the measurement techniques for a set period or timer. The example is usually somewhere in the region of 440 degrees Celsius, and the setting is usually somewhere in the region of about 3.25 seconds for a particular case or type. But when this signature differs from one case to the other, then obviously you need to change the approach. In other words, the timing needs to be variable. It needs to be variable. And how are you going to determine that variation? The exposure time. It's simple. You detect the thermal signature or the glow image of the case. And we spoke about it a bit earlier on, where it's very difficult to actually see the correct level of glow and to distinguish the correct level of glow. The problem, of course, when you do this distinction is the visible radiation occupies a very narrow band of the spectrum. And it's somewhere in the region of between 400 and 760 nanometers. Annealing temperatures range from 600 degrees Fahrenheit, which is 315 degrees Celsius, to 800 degrees Fahrenheit, which is somewhere in the region of 425 degrees Celsius. Now, you would find recommendations of somewhere in the region of 370 degrees Celsius. Now, on what is this based? It has to be based on the particular shape, size, form, composition of a particular case. Earlier on, we discussed and I mentioned that military brass is annealed at 270 degrees because it has very specific prescriptions, and the intent is only to use that brass once. So let's come up with, let me give you an idea of how some of these brass compositions actually look like. We all assume that cases or brass, even within a particular brand or even within a particular batch, are exactly the same. And I guarantee you it is not. So let's look at a few examples. Let's take Winchester cases, for example. If it's manufactured from series C26000 material, what you would typically find is copper at 72% and zinc at 27%. Also keep in mind that there are other impurities or fillers in between in very small percentages, and that makes a big difference. Norma, for example, you would find 77% copper and then the zinc relationship to that. Federal, for example, pushes high levels of copper at 78% and zinc somewhere in the region of 20% with a number of other fillers. So it is clear and practical to understand why from brand to brand, batch to batch, and even from case to case, the correct or the ultimate annealing exposure time has to be intelligently managed in order to give you the perfect level of annealing. Van Zyl, thank you for the demonstration. It is really impressive. The features is absolutely out of this world. I've made a few remarks now for our audience sake in terms of why, in principle, time-based annealing can be compromising. I still say that thermal signature, what is the term you guys use?
Glow signature.
Glow signature, right? I think that is by far the best platform solution. I see it when I use my machine. You can clearly see the differences in time exposure, right, in terms of composition.
You're 100% correct there, Christopher. I think to some extent you might be able to use the difference from one case to the other in time to actually sort your cases.
I do exactly that.
And
I do exactly that.
The color is misleading.
Yes.
From brand to brand, even the same batch, you'll find it gives an indication. That's why I said earlier that to set it up to be safe, do your setup, do one without lights. Just make sure you see the heat distributing to the right places, and then you know you don't want to see that much glow in the light conditions.
Exactly.
And then the myAnnealer will ensure that all the cases are completed, well annealed with the same glow signature.
Exactly.
So time bias is almost yesteryear.
Exactly.
This is the way to go forward.
No, I agree with you.
And the proof, I think, is already from the customers.
No, I agree with you. I agree with you. I don't do any time-based annealing anymore. I just don't. Okay, so it is confusing initially when I started out with the solution, now remember, I'm a grade 3 thermographer, and I've had a lot of experience when it comes to thermal signatures, emissivity, and everything that goes with it. And initially I was surprised and I was concerned because I use fairly good quality brass, especially for the long range rifles. You know, 416 Hellfire brass, 416 Barrett brass, etc. And initially I was concerned about the so-called annealing footprint, or the image that the post-annealing leaves, the impression it leaves on the case. And we are all used to a relatively, I don't know, serious, you know, you can see something happen. But what I found is that on some cases, there was basically no signature left. But the neck tension, and I had it scientifically tested, that neck tension or coaxial tension was absolutely consistent. So what I'm trying to say is that we all have, it's a paradigm that we have to move away from. That once my case is annealed, it needs to look completely different. It's not the case at all.
Visual inspection is totally misleading.
I agree with you.
You can imagine getting this far. I've got buckets full of old cases that I've annealed.
Yes.
And it was amazing, like even from a specific brand, in one batch,
yes,
the discoloration is not the same. Because
exactly.
Of the composition. And even if you now get to the silly level where you totally overheat the case,
yes,
you might sometimes see little black spots.
I've seen that.
That is the indication of the impurities.
Exactly.
And the whole composition and all that. So definitely, obviously we can do time-based if you want to, happiness, but our glow sensor that we've developed, I think, is magic, and it works very well. Absolutely. And I think it will be used for a long time to come.
No, this is next level. This is the way forward. If we take a look at this case example, this is a classic 30-06, right? That was annealed to the correct temperature according to the thermal signature, and this is my 338 improved. And guys, I shoot 2 miles with this rifle, and as you can see, there's basically no annealing indicator. And these are consistent to the T. So the point is that one should not be confused, or one should not be misled by the actual visual inspection. Right, if you're uncomfortable with this, then take 2 or 3 and anneal it a bit more and wherever until you are happy and satisfied. But the point is that visual inspection is not the solution, because you can technically anneal from 270 degrees all the way to 460. The point is it the correct thing for that particular case and application?
And I want to get back to consistency in process. So why I'm saying this, let's say your process, for some odd reason, there's no bad stuff about it, I'm just trying to explain. If you take your case, then you deep prime, and then you anneal, and then you wash, keep it the same.
Exactly.
That ties up with emissivity.
Exactly. Exactly.
Because if you then decide, now I'm first going to clean and then anneal, so be it, but keep on doing it. Your process must be consistent, like we said earlier in the whole shooting process.
Or you need to reset it. If you change your process, then you have to reset your annealing protocol.
Christopher, that's a very important aspect that you mentioned. If I anneal this at, say, 850, and I do a coffee break and I anneal it again, it will be exactly the same.
Exactly.
It's not adding to the previous.
Yes.
So if you say you before cleaning you do a anneal and you then clean them and you anneal them again, it should in theory be exactly the same. Yeah. If you can overheat but not over anneal. So if the level is the same, it's nothing going to change.
I agree.
So
I agree. Well, Van Zyl, thank you very much for a brilliant interview and demonstration. It is really well appreciated. So folks, there we have it. myAnnealer. By far the best quick anneal solution that I have ever seen and used. It is accurate, it's practical, it's fast, it's efficient, and it works every time. And do you know how it works? It's simple. Go take a look at the scores. Go take a look at the scores at 1,000 meters and 1 mile and 2 miles. Folks, thank you very much for watching. Now, the big thing. You definitely get this product, definitely get the Bakgat stamp of approval.
Now, this is a Bakgat idea. Christopher, thank you very much.
You're welcome,
Much appreciated.
You're welcome.
Bakgat
is all.
I will wear this proudly.
Please do, please do. Bakgat is all about supporting local brands, South African brands. And folks, if you're watching this somewhere in the globe, I can tell you with confidence, this is something you want to invest in. Thank you very much.
Super. Have a splendid day and thank you again.
You are welcome. Jonas, jou hare. Alraai. Okay, kom ons maak hom mooi.